Alright, for calculator questions, it says a new car was purchased for $40,000. The car depreciates at a rate of 22.5% per year. These are the four formulas that we have. For depreciation, we're going to use an exponential decay formula because it's going down. We need to remember that our rate needs to be written as a decimal, so this is 0.225. When I plug everything into the formula, it's 40,000 times 1 minus 0.225, and we're raising it all to the 5 because it's 5 years. So I'm going to have 40,000 and 0.775 raised to the 5. And I'm just going to type that all in my calculator just like that. 40,000 times 0.775 raised to the 5th. And I get 11,183 and 26 cents. It's money, so we want to round to cents. Number 2 says a piece of jewelry was purchased for $275. It increased in value by 12.5% per year. How much is it worth 20 years after it was purchased? So this is getting larger. It's increasing, so it's a growth formula, so we're going to use this one. We started with $275. We're adding 12%, so that's 0.125, and it's 20 years later. So 275 times 1.125 raised to the 20th. And we type that straight into our calculator. 275 times 1.125 raised to the 20th power. $2,899 and 90 cents. All right, number 3, we've got a few different accounts. This account is compounded weekly. Account number 2 is compounded quarterly. And then account number 3 is compounded continuously. So this is going to be our formula for compounding interest when we have a specific amount of time. The N is the number of times per year it's compounded. This is our formula for continuous. So let's go ahead and we'll do account number 1 first. Number 1 has an interest rate of 4.5, so that means my rate is 0.045. Compounded weekly, there's 52 weeks in a year, so my N is 52. So this is going to be 1,000 times 1 plus 0.045 all over 52 raised to the 52 times 5 because it was for 5 years. When I go to type this in my calculator, it is 1,000, put the parentheses, 1 plus, and then I hit alpha y equals, pick the fraction button, 0.045, use the arrow to go to the denominator, 52, over to get out of the fraction, close the parentheses, raise it to the 52 times 5. Hit enter, and I get $12.52 and 20 cents. Okay, account number 2. $1,000. The rate is 4%, so that's 0.04. Quarterly means my N is 4. So 0.04 over 4 raised to the 4 times 5. Now I'm going to save some time on my calculator, and I'm going to hit second enter, and it puts the thing right back in there. So I can just type over what I have, so I don't have to like retype everything. I mean, you can just retype everything if you want, but it just saves a little bit of time. So $1,220.19. Option number 3 was continuous. e raised to the, this is going to give me 0.035, and the years are 5. So 1,000, the e is the second in the natural log, and 0.035 times 5. And I get 1,191.25. So which one's the greatest? It's going to be account number 1. All right, next, evaluating. This is just typing these into the calculator. There are 2 ways to do this. You could use change a base. Change a base means I'm writing it as 2 logs, right? I'm dividing. The one on the bottom stays on the bottom because our calculator knows how to do base 10. Okay, the other way to do this, I'm going to do it this way first. So I did log of 8 divided by log of 3, and I get 1.893. If I did it the other way, I hit alpha, y equals, and I go over to the function menu. On the newer calculators, you can use the over button and get to the function menu. On the older calculators, you'd hit the window button and it brings up the function menu. And then we're choosing option 5. With this feature, you can just type in the base, use the arrow to get out of the base, and type in the other part and use the arrow to get out of it and hit enter. You see you get the same answer, so it doesn't matter which way you do that. For the natural log of 6, we have a natural log button, so we just do the natural log of 6. I don't have to type in a base for this one because when there's no base written, the calculator understands that's a base of e. So 1.7912. Okay, solve the equation. You can do this a couple ways. One way to do this is to isolate this part because that's the part that has the variable in it. I would subtract 5 and I get 6 times e to the 4x equals 24. I could divide by 6 and I would get e to the 4x equals 4. At this point, I have an exponential function set equal to a number. One way to solve this is to change it to a log. So natural log base e of 4 equals 4x. All I did was rewrite it as a log. I used natural log because the base was e. To get x by itself, I would divide both sides by 4. So this is what I would type in my calculator. Natural log of 4. I don't have to do anything with e because when the base is e, the calculator already has a base of e. Natural log of 4 divided by 4. And I get 0.347. Next one. I have a log question. I would rewrite this in an exponential form. So 5 to the 3.5 equals 4x plus 1. Now I could put this in my calculator right now and round, or I could keep that and just take my steps, right? Subtract 1 from each side. And then to get x by itself, I would divide by 4. And then x is alone. If I leave it like this, there's less rounding, so my answer is more accurate. So it's 5 to the 3.5. I use my arrow key to get out of the exponent, minus 1. And then I can hit enter and divide by 4. Or I could have put all of that in the top line of a fraction and then 4 in the denominator. Doesn't matter, you get the same thing. Okay, so 69.627, either way you do that question. So those are your calculator concepts for your test.